Sorry about the dryness, but we do have to get these. And they, let me do it this way. So class, let's go for it here. We're going to try to get through all these methods right here about quadratic equations here. Part of our class in Algebra 2 is actually exploring this one right here. We're going to learn a lot of different methods to solve polynomials. Those are so important because in math, whenever we model things, they are sometimes second degree, sometimes third degree, sometimes fourth degree equations, depending on how complex things get. And so if we can figure out how to solve polynomials, that's super cool. This one breaks up into two different pieces. If you have one radical, if you have two radicals, you got to do it differently. And then absolute value here. So let's keep on going. We got to keep going. Then we'll be done with solving. Go on to some other stuff here, but that one got to do. So I'm going to skip number 50 something or other, 52 I believe. But jump to 57 on our notes. Ooh, raise your hand if you printed out notes, have them with you, all the good stuff here. Yes, I got another convert to printing out notes. That's cool, okay. Otherwise, let's jam. We're gonna start off pretty easy. Factoring method, something we learned last time. Then we got the square root method, completing the square method, and the quadratic formula. So all these guys really go into how complex you need it. This is the easiest one. If it looks easy, you factor it. We're good? This one is the square root method. If you have it in a certain form, we do it that way, but not all the time. We're good? If it's in a certain form. Completing the square, if you need to do it for the sake of the problem. Usually we do this to set up for graphing. This is the graphing setup way of doing it. And then anything beyond that, we just stick it into quadratic formula. Okay, we're good? So there it is. 57, try yourself just for a quick one. I think you guys know factoring. You should be able to factor that one. No problem at all. Ooh, it's not even wrote down the quadratic formula. That is so cool from memory. It pays to know the quadratic formula. All right, most of you guys are going with it here. You just walk around, see how you guys are starting off. And we're talking about two easy.
I didn't print out that thing for English. Yes. Why? What was your
All right, class, let's go for it. I think most of you guys tried it here. Let's jam. And I got 5 people did it easily, super easy. So whenever you're factoring, you do want to set it equal to 0. That is the first thing you do. You want the whole entire equation on the other side. With that, and those that did it, we went up to do it like that. Is that right? And then two numbers, the x squared comes down. X times x gives you x squared. And then we got our x box over here. So I need two numbers, multiply to -8, add to -2. And this one we only do if we need to. We good? If you can do this in your head, don't do more work than you have to. We good? You can say, okay, two numbers multiply -8, add to -2. Answers are?
-4 and 2.
-4, +2. I'd go with that. And then we have something called the zero product property, which means this guy's be set equal to 0, and this one gets set equal to 0. And then we solve each of them. 4, add 4 to both sides, subtract 2 from both sides, and we're done. Are we good? Okay? Everybody okay with A, B, see the board? Oh, and you guys see the board? Okay. Camera's not blinding you on the board. Okay. Where does this guy come from? This guy comes from a property from algebra. It's kind of like this. If I know two numbers, A and B, are multiplying to give me 0, what do I know about A and B? One of them 0, has to be. There is no other way. 0 is such a special number. One of these guys will have to be 0 for this to be 0, or both of them are 0, right? Okay, does it work for any other number? Like this one right here. If I say this, da 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 da. Do I know anything about A and B?
No.
I have no clue. Right? Because this could be, I don't know, this could be 1/2, this could be 4, right? This could be 1/3, this could be 6. Multiple, infinite number of possibilities, right? But when it said equal to 0, I got something here. I got them nailed down, but okay, all right, we're good there. Next thing is when we're going to start doing application problems, another little problem. If this was like the distance from, if this was time for a model rocket to go up in the air to reach 200 feet. If this was this, what answer would not make sense?
-2.
Yeah, so for abstract math problems, we accept both answers. Once we get into applications of things doing something, rockets going up here or distance going this way, then we're gonna have to be thinking about our answers, we're good? So that would go away, but for now, that's cool. Okay, another one? All right, anybody know? I'll get it here. X squared plus 4x is equal to 12. All yours for this one. I'll set that up and then I'll start going over here. Let me start erasing things and setting up the next problems. Now let's see if we can get through all of these here. Number 65 has a fraction inside it. What do you want to do there? All right, some people are done. And so first things first is move it over so it's set equal to 0, just like our previous one is. Right first. What's the fraction? 3/4. Okay, cool. All right, so if you guys are starting to work on 65, I'll tell you this, we don't factor fractions usually, so get rid of the fractions first. All right, with this one, I am going to move the 12 over, so I think it has to look like this. Everybody agreed? Dylan? Yeah, absolutely. Thanks for asking. Okay, boom, there's that. And I got two numbers. X times x gives me x squared, but I need two numbers multiplied to 12, that have to be 4. -6. How about +6, -2? Does that work for the factoring part? Does the signs have to work out? But Abe is correct. The easiest way to do it, notice the answers here. It goes from a -4, gets to a +4, goes from a +2, gets to a -2. So the easy way to do it is you just go down, you change the signs, and you're done. Are we good there? All right, next on the list is fractions. Fractions. Okay, so notice these guys do not have fractions. It's kind of tough to factor fractions because they think, okay, what number multiplies to 3/4? No, crazy. So how do we get rid of fractions? Anyone? Multiply. Let's multiply both sides by the denominator. So I'm going to multiply this guy by 4, and I'm going to multiply this guy by 4. And so if this is the case, 3 stays as is, because the 4's will cancel. 4 times 8, ooh, that's 32. Whoa, that times that is 80. All right, the good thing is 0 times 4 is still 0. Oh, we got ourselves a tough one. Anybody factored it down yet? Anybody got the answer yet? So a few things here. If I were doing this, I would probably just put it into a
Calculator.
quadratic formula at this point, right? I would not even mess with it, but just for practice sake, let's see. Anybody got an answer? Anybody got it? Let me try. Let's see if we do it the long way. It could be also not factorable. So, do you guys remember Xbox 360? It's this times this to give you over here, is that right? So big numbers here. I think it's 240, and I need a 32 down here. So 3 times 80, yeah, that's 240. Abe, got an answer yet or no? No. 240, I need two numbers, multiply 240, but add to give you 32. Multiply to 240, add to 32. That was a guessing game, isn't it? A little bit of a guessing game. Dylan?
Wouldn't this be 40 times
40 times 8?
That doesn't add to 32,
Doesn't add to 32.
8? Negative 40 times negative 8.
but then that would still not add to 32.
20 and 12.
Yeah.
20 and 12? Let's check. Yeah, I think that just might do it here. 40. No, 20 times 12. Yeah, does it?
Yeah.
Yeah. Placeholder. 0, 2, and I think we are good. There it is, 20 and 12. What do we have to do when we do Xbox 360? We gotta do something.
Divide it back by 3.
Divide out the 3 again. Yeah, we multiplied with 3 in the beginning. We divide out the 3 at the end. That does not divide. This does. That's awesome. That's 4. So anybody, please help me out. How do we write the division right here? How do we turn 20 over 3 into my binomial over here?
Yes, plus 20?
Yeah, that denominator there, that 3x plus 20. Boom, and this one's going to be x plus 4, because there's no, technically there's a denominator. What's my denominator right here that I don't write down?
1.
There's a 1 here, right? 1, and that 1 carries over here by the x, and 1 times x is just x. Okay, so there's that. Okay, guys, real quick, I'm not teaching you this whole thing, right? Because you guys learned in Algebra 1, right? So this is just kind of a quick recap of things. So hopefully learn it in Algebra 1. So let's take a look at the fast things that happen here. So 3x plus 20 equal to 0, is that right? We're going to do what with 20? Subtract it, gets you over here to negative 20. Divide by, those should be a 3. Divide by 3, and notice what our answer is. Back to our Xbox 360, is that right? So then could I go from here straight to here? And just take the opposite? Absolutely. That's why this is such a cool thing. No wonder they named a video game console after this. So we got that one. Then from here, we go over here, we get right down. Negative 4, are we good? Don't need to do the work, you just take it from there. Okay. Factoring, are we doing good? Set it equal to 0, and then do Xbox or Xbox 360. Let's jam. Next is, let's see, I think. Yeah, next one. Completing the square. Or the square root method. Let's go square root method now. We're gonna get through all 4 of them hopefully today. All right, I think you were on 70. All right, this one, the square root method. Easy. We don't do it all the time. We only do it if it's already in a perfect form or a perfect square. So, are we okay with x being the perfect square this time? So all we're going to do, the square method just says this. I'm going to take the square root here. I'm going to take the square root here. Easiest thing. Okay, anybody did something in algebra? What else did we put on there when we did this? You remember doing something in front of the square root?
Plus or minus.
Plus or minus, yeah. Technically, we do this. We have to put a plus or minus here and a plus or minus here. We good? That's the way it officially mathematically works. But what we do is we cross these out. We good? And mathematicians, I gotta say, they're like lazy, okay? So if you're gonna cross something out, are you gonna put extra work here? So over here, we don't put the plus or minus, because we know we're gonna cancel them out anyways, we're good? So the plus and minus only go on that side. So answer is plus or minus, and 169 square root of 169 is 13, done, we good? And another easy one, again, lazy mathematicians here, we put plus or minus in front. So I don't have to put negative 13, comma, positive 13, okay? If you wanted to, if you want to do it the long way, then you could have done like this. That's the long way. Why go the long way when you don't have to, good? Okay, now let's go with another perfect square. How about this? 76. X plus 3 square 25. Ooh, I like that. Alright. Talk to me here. Are you? Sorry.
X plus 13, X plus 3 on mine.
Oh, X was 13? Dylan is totally correct. Here it is, sorry. X plus 13 over here. Squared equals 35.
25.
25. All right. All right, are we good there seeing what kind of form it's in though, right? That little perfect square binomial. Cool. And most of you guys are done already here, so I'm gonna do it quickly here. Boom, that cancels. No need to put plus or minus here, only on that side. X plus 13 is equal to plus or minus 5. Ooh, not done yet, because we haven't solved. So I think what we have to do is we have to subtract 13, subtract 13 here, and we gotta watch it. We're gonna write this negative 13 in front, and we're gonna have to do these two problems here. Negative 13 plus 5. Negative 8, I heard? Okay, negative 13 minus 5.
Negative 18.
Negative 18. Okay, I'm good there. There's my two answers. All right, one more type we should, of this case here. I think it's 82 on our notes. Anybody give me is it X plus 4? All right, this one, again, same exact concept here. I have two perfect squares. That's cool. I can do the square root method. Oh, except for this one, a little bit of a trouble. Remember how we used to always put plus and minus on one side? That was nice because we had a single number. Like this one turned out to be a plus or minus 13. On here, I do have to put a plus and minus on one side because that cancels, but then I have to put this guy here. We good? So kind of careful on these ones. If you have two perfect squares on both sides, I have two different possibilities. This is a possibility. This is my plus or positive possibility. Or I have x plus 5 is equal to a negative of this stuff. Are we good there? Does that make sense? There's two different possibilities for it. We got to take into account both possibilities. Can you solve each of those?
You can solve the one on the right.
Yeah, I saw the one on the right. When you saw the one on the left, what happens is these guys go away, and this one's a no solution.
5 plus 4.
Yes.
Okay, but then we jump to this one, and we have ourselves negative x minus 4, and let's go here. Add x to both sides. 2x plus 5 is equal to negative 4. And you guys are sophisticated Algebra 2 students, so you guys can move things in your mind. Negative 9. Negative 9 halves, are we good? Okay, the square root method, we're good? Next is completing the square. Alright, these ones gonna look easier to begin with. So 84 is by completing the square. I think it's ing, yeah. Completing the square. Alright, this one, primarily we use it when we were going to set up for graphing. This is the graphic setup. Alright, and something we got to go back to algebra with when we did factoring. You guys remember, in fact, let's do this here. You guys tell me, what was so special about these type of problems? I'm going to just start listing them. In fact, I'll list them in order. 3, 2, 4, plus, sorry, I had to write them in between here. This is going to be 8x plus 16. This is going to be x squared plus 10x plus 25. And maybe 2 more. All right, you guys talk to me here. Let's have a little discussion here. What's so special about those perfect trinomials?
They're all perfect squares.
They're all perfect squares. Cool. So I'm thinking, let's just jump and do this one here. This one is going to be a perfect square of something, 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 and something, and something. And then right along here, sorry, something. So the question is, can we get to that something really quick?
You can just divide the last number by, or you can find the square root of the last number. So the square root of 1 is 1, and so it's x plus 1 for
Cool.
the first one, and then for the second one, the square root of 4 is 2. So the answer is x plus 2.
Awesome.
And you can square it on like that.
Yeah, so this one is going to be x. Let's do this one because it'll be easier. This is going to be x plus 4, because Owen says, what you do is you just take the square root of this number. Square root of 16 is 4. And we found our stuff. Square root of this one is 5. But how do you know that it works magic to get you over here?
That's double.
Oh, okay, hold on. So,
Good job.
Camille, is that you? Square root of 25? Oh, Isabel? And then if you double the 5, 5 times 5 is 10. Ha ha ha. Of course I put a trick in here. How do I do this? How about if I just take this away? How do I go from the middle to the intern? I know. I still want that perfect square. But how do I know? How do I know this should be 25? How do I know this should be 36?
Divide it by 2 and square it.
Abe says divide this guy by 2, which will give you 6. You square it to give me, I'll read it right back up to 36. Like that. So this would be x plus 6. Let's try it again. 14 divided by 2? 7 squared? 49. Done. X plus 7 is my binomial that's being squared. Are we good? Super easy. You guys are super cool. Okay, boom, 5, 25, done. And then it's x plus 5. Hey, you know what I noticed as well? When I divide this by 2 and I get my 5, that's also the same thing that goes over here, right? So when I get my 6, before I square it, I already know that my 6 belongs over there. We good? So, a little bit different method. This is called the completing the square method. Here we go. Completing the square, we're going to take this 3, we're going to move it out here. And we're going to leave a little bit of space. And we're going to move it over here, just leave that little space in there. Oh, we didn't do negatives, huh? We didn't do negatives yet. So, can we go back to this one? Boom, if I make this into a minus 8,
It's x minus 4, because when it's squared, it's still
divide by 2, it becomes a minus 4. If you square a minus 4, hey, that's cool. At the end, it still becomes a 16, right? Because negative times a negative is a positive. We're good? But what happens here, this minus 4 comes over here, so it's x minus 4 at the end. Are we good? Talking fast. Charlie, are we good? Okay. All right, go for it. You guys tell me, what should I add into here?
Positive 4.
Now, take my negative 2, divide by 2, gets me a negative 1. Is that right? Oh, positive. Who said positive 2? And if I square it, I'm going to add in a positive 1. So, you guys know this from algebra. Whatever I do to one side, I got to do to the other. So, boom, are we good? So here's the completing the square method right here. Now that's done. That becomes a 4 for me. That's nice. This becomes x squared minus 2x plus 1. But what is my perfect binomial?
No, because -1 has 1. But I'm lost.
You just said like 3 seconds ago, oh, I'm not that stupid.
Wait a moment.
It's x
There's no
minus
square
one.
root 2.
There doesn't need to be, the equation ends in 1.
Oh, yeah, wait. I'm still lost.
The number that we took out before we squared it? Negative 1? So that means this probably is going to be like this. Is that right? Abe, did we get back you back to normal?
No.
No.
It's a lost cause.
We lost Abe.
This is my
Okay,
first
it's fine.
leave. I'm lost.
Do this again.
Abe, this one is, let's see, x minus 1, it's the doubling factor, right? So here's x squared, but here's your negative x. Here's another negative x, there's your negative 2x in the middle. We're good. So it's the negative 1 plus another negative 1. Did we?
I was switching the multiplication and getting it.
Gotcha, yep, totally thought that was the case. Okay, hey, real quick here, to finish this off, isn't this the square root method now?
Yeah.
Can you guys finish it off with the square root method? So yeah, one folds into the other one. Okay, let me get rid of this stuff. Boom, and I think I do this. I do a square root here, I do a square root here, plus or minus, and I go x minus 1. And how about a plus or minus 2? Plus or minus 2. I add 1 to both sides. Okay, here's my practice again. So, and in fact, if you can write it like this, that'll sure help you out. We have a plus 1 in front, and then we have a plus or minus 2 in the back. I got my 2 answers, and the answers are
3 and negative
3 and negative 1. Okay. Just out of curiosity, if we were just to factor this right here by x box, what do I get over here? 2 numbers multiplied by negative 3, I have negative 2.
Negative 3 and positive 1.
Are we good there? If we were to take the opposites of these guys, do we get this? Are we good? So yeah, it all runs together. We're good? So why do we do the completing the square method? It's when it gets a lot more complicated, when you can't do this. Because factoring only takes you so far. In fact, factoring can only give you guys integer answers or fractions. That's it. You can't do anything beyond that. The square root method can get you beyond that. So let's jam. Let's you guys try this method again. All right, you guys tell me, when are we out of here? Just to make sure. 9:25, okay. I think we have enough time. Let's try this one. Let's try this one together. This one's a toughie. Or should we? You guys talk to me. We need more practice with this one, just to try it again, something like that? Okay, yeah, I see. So let me put a little star, it's an extra problem. Star is the extra. I'm gonna put in, 12x plus 14. There it is. Okay, can you guys go beginning to end? That's what I need you guys to do. Beginning to end on this one. Yeah, I want it this way, because it'll show you something else here.
Let's see.
You're talking
We're
about-
gonna add 36 to both sides.
Subtract 50.
What? How the heck did you get there?
All right. I think, yeah, quadratic formula is gonna be easy here. So let's see, what do we got here? Everybody made it to this step over here. They moved the 14 over, made it negative 14, is that right? And then we have negative 12, and then off to the side, negative 12 divided by 2 gives you a negative 6. And if we square it, it should give you a 36 up here. We good? 36 there, so therefore I'm going to add 36 here. That should give you 22. Awesome. Okay, this one's going to give us, well, I think I got this. This is going to be x minus 6. Everything agreed there. X minus 6. Cool. All right. A little bit different from that one. If you do the square root here, if you do the square root here, plus or minus, 22 is not a perfect square anymore, huh? Bummer. 22 is made up of 11 and 2. There's not even a perfect square inside there, huh? So we're gonna just kind of keep it, leave it for now. Here's what we got. These guys cancel. Plus or minus the square root of 22. What should we do to solve for x?
Add 6 to both sides.
Add 6 to both sides. And how about x is equal to 6 plus or minus the square root of 22? I'm done. Are we good? I don't know what the exact square root of 22 is.
Yeah, if it's still got that way, it's
If I were to, if the book said find to the nearest tenth of a second or something like that, then we would reduce it down. But if, as far as abstract math is concerned, I keep it like that. Okay, you guys ready for the tuffy? Let's do a tuffy. I'm going to put a number.
Which one's going on this page?
In fact, look here. Does this guy look like a quadratic formula answer?
Kind of.
Yeah.
It does, huh? It's getting there. Also over here, if you guys look at it, is there any way to do this? Two numbers multiplied by 14 add to negative 12. Dylan says no. 2 down is 1.14, actually, negative 4. I don't think so. So this one cannot be done by factoring. No. Cannot be done by factoring. Because we even know the answer. There's no way I can get an answer of factoring into a square root of 22. We good? So this little square root method, completing the square method, allows me to have answers that I can no longer do by factoring. Okay, tough. You guys ready? 9x squared is 8. 9x squared minus 12x is equal to 14. Okay, what makes it difficult is the 9 in front. That 9 is not very nice. So, we got our space. So let's do this one together, because this would be... Leave a little bit of space, move the 14, make sure we've got that. Can I just say again, this is going to be not very nice. But we got to do it. So notice on these ones before, we always had just an x squared by itself, right? X squared by itself, x squared by itself. On this one, we're going to have to do this. We're going to have to factor out. Oh, this is so fun. We're going to factor out a 9. So this should kind of tweak your brain a little bit here. Okay, it's 9 o'clock. The phone turns on at 9. How do you factor out?
I mean, you don't actually have to factor out the 9. It's still perfect square with the 9 on the equation. It gives you, oh yeah, this is 3x. I thought you were talking about that. 3x minus 2 squared.
Oh, okay,
So
let's do that.
Put a positive 4 in at the end there.
Gotcha, okay, so Owen is saying do this, which we will do. Let's see what we got. Owen says take out a 3, because 3 goes in 12 to 9, is that right?
Yeah.
So let's talk about it. This one, and if that's the case, we get 3x squared plus, minus 4, is that right? X? Oh, and did you say take out the x as well? No.
You can just, I mean, let me see. I suppose you can do it that way, yeah. I just did it where I added it, so if you add 9x squared minus 12x plus 4 is a perfect square. So I added
Gotcha.
4 to the end there, so you add 4 to the 14, so now you have 9x squared minus 12x plus 4 equals 18. And then the square root of that is, or so it would be 3x minus 2 squared equals 18 with the square root of 18. So that's
Gotcha.
gonna make
Okay,
it much
cool.
more necessary addition.
Owen is thinking 5 steps ahead. We're gonna let him be in his world, because he's cool like that. It is the correct way to solve it. And it's because, you know how we were able to factor and also do it the other way as well, right? Because these are easy problems. So Owen says this initially here. I'm not going to follow Owen. We good? Not on this one.
It's
But that
probably
would
not a
have
good idea.
been, but that would have been a good one to follow. So I am going to, because we're doing the completing the square method, right? This is the method. So we're going to do this. We are going to take out that 9 from here. Because I want this guy to be a perfect square. So now the question is this: how do I take out a 9 from 12? Did you guys ever do that? Ever take out a 9 from 12? Because remember, whenever we factor out a common, we always factor out a common term, right? It's always the greatest common factor, right?
Yeah.
All right, let's go with it here. So let's go with, if I were to take out a 9 from 12, notice that 9 would have been on the bottom, right? And if I take it out, these guys would cross out, give me back my negative 12. Are we good? So here's what we do. If I take out a 9 that's not originally there, I keep this in, and what I do is I just put the same number on the bottom. Because once I multiply through, notice there's my 9x squared. When I do this, my 9's will cancel and give me back what I had originally. We good? Okay. This is the toughie. Let's put the thinking caps on. Let's go for it here. So can I reduce this? thinking like 4/3, is that right? 3 goes into both those?
Yeah.
So, how about 9 on the outside? Negative 4/3, leave a little space. I got 14 on this side, okay. Ready? We're gonna take negative 4/3, and we're gonna divide it by 2. Divided by 2 is the same thing as multiplying by? No.
No error. How did
Not
you
in this,
know error?
not in this universe.
It's not plus
1/2. So dividing by 2. So dividing by 2 is the same thing as multiplying by 1/2. That's cool. Okay, so let's see, the 4 and the 2 could reduce. That's a 1, that's a 2. Negative 2/3 is what I have. And I'm going to square it to give me this. So I think I got myself a 4/9 over here, is that right?
So complicated.
Real quick here, if I add 4/9 over here, what should I add over there? Not 4/9.
4.
A 4, who said 4?
Because
Is
it's
what
multiplied
time?
by 9.
Yeah, notice the little multiplier over here, right? Multiply this guy. So to this whole thing, because I have a multiplier of 9, if I multiply the 9 over here, the 9's cancel, I'm technically adding a 4 over here. So I'm adding 4 over here too. Okay.
Wait, I have a question. Why would you want to add fractions to the problem though? Like if you could do it without fractions?
Gotcha. So if I saw this and I said, and it says solve, I would probably do this by factoring quadratic formula. Good? So we'll get to quadratic formula. I just want to show the difficulty of completing the square
Okay.
if we do have to do it that way.
I tried solving a quadratic formula and it got pretty weird pretty fast.
Oh, okay.
This one in particular.
Did they answer at the end?
No, because like, once again, take this with a grain of salt because I might have done this wrong, but I ended up with, negative 12 plus minus the square root of 648 over 18.
Ooh, ouch. Okay.
Yeah.
Let's see if we get there.
You got it there.
That's good, yeah. Let's go with it. Let's finish this off though. I think, let's see, I think we need to do this here. 9 is on the outside. I got x minus 2/3, everybody agree there? Squared is equal to 18. You guys tell me if you guys agree here. I'm gonna kind of just push to the end here. And you guys got that one. So we divide both sides by 9. All right, let's divide both sides by 9, because this guy over here, that's a perfect thing to do. 9 here, 9 there, and I'm bringing it over here. X minus 2/3 squared is equal to 2. Everybody agree with 2? Just watching my math, I could make a mistake. Never have made a mistake yet. Take a square root, we good? Take a square root, plus or minus. And I gave myself x minus 2/3 is equal to plus or minus root 2. Love that. And then I add 2/3 here, I add 2/3 here, and I give myself x is equal to 2/3 plus or minus root 2. Dylan, I don't know, I'll check your work afterwards here, but I got like
Same
that.
as that.
Owen, did you get the correct answer?
We got something different, but because you've got, I don't know if
Is the
it's,
square root of 18 over 3 the same as the square root of 2?
no, Abe.
Are you sure?
Wait, actually, it could be.
It could be.
Square root of 18 is the same
We
thing
got
as 9 times
2.
2, 3 over 2. So if you guys had this, then you got the same thing.
I had that.
Yeah, so,
That, okay, cool. It just,
Let's
you
go.
kept,
except for our way had no fractions in it. It's not actually 5.
okay, guys, this was the tough one. If we got through this one, we're good, right? Completed the square. So here's the problem, is that completing the square takes a long time, especially when we get numbers that are just not so very nice. So eventually, the quadratic formula was known. See, the Babylonians and the Egyptians, they didn't have variables like x inside them. They just had problems. They said if you take a number and you square it, and you multiply by 9, and you subtract the 12 times of that number, you get 14. right? And so they knew the quadratic formula, they just didn't think about them as variables. Okay?
That must have been so confusing.
And so, totally confusing.
Or-
So, let's go with quadratic formula. This is, the quadratic formula technically is the fast way to do this. We good? And I think it's, yeah, this is algebra 2. We can probably do this here. Let's see if we can. Let's do this here. Let's make the quadratic formula. So, I'm going to start off like this. ax squared plus bx plus c is equal to 0. Let's make it real quick here. We have enough time. When are we out of here again?
25.
Okay. So, see if we can follow the process. We just did it in the previous number, right? See if we can follow the process. So we have this. We have ax squared plus bx, and then we move the c over here. We good? Boom. Next thing we did is we factored out the a. And if you factor out the a, it gives me x squared plus, anybody?
B
Yeah.
b over a. Thank you, class. If we take the b over a and we divide it by 2 or multiply by 1/2, we get ourselves b over 2a. And we square it to give us b squared minus 4a squared. Are we good there?
Mhm.
Huh. What have we added to this side?
That whole fraction
A lot.
Ooh, that whole fraction without a,
without the end, so.
without the a. Remember that? It's this. So it's we added b squared minus 4a. Tell me if you guys agree. That's what we added to this side.
Oh.
We're gonna add it to this side. We're gonna say b squared minus 4a. All right, I think we got it. Let's bring this guy down. This is a over here. This is x plus, I think, b over 2a. Tell me if you guys agree there. And this we're going to do a little bit of work. Let's get common denominators here. So that's a 4a, that's a b squared. Tell me if you guys agree. We're going to multiply a 4a here and a 4a here. This would be a minus 4ac. Everybody agree? Just talk to me. We're jamming with 2 minutes left here. So if I do this off to the side, this becomes 4a on the bottom. This becomes b squared minus 4ac. Talk to me. How about this? Tell me, still following along? Kind of following along? You lost me a long time ago. Okay, okay. So about a quarter and a half. This guy, let's bring this guy down over here. We got b squared minus 4ac over 4a. And now I get to divide, let's see. I get to divide by this a. If I divide by this a, I technically multiply by 1 over a. Tell me if you agree there. Dividing by a, multiplying by 1 over a. So now I have x plus b over 2a. Almost there, guys. Now I got myself b squared minus 4ac over 4a squared. Tell me if you guys agree.
You wrote b to the 4th.
Talk to me, Landon, what I do.
You wrote b to the 4th.
Thank you. All right, then I take the square root. Square root here, square root there, plus or minus. And I got myself this over b squared minus 4ac square root plus or minus. And this guy becomes a 2a. So I agree there. And then if I subtract b over 2a, see if this makes sense. This will be a negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And we have arrived at the quadratic formula. Da, 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 da. Let me erase this part right here. I think you guys know how to use the quadratic formula. But is this the quadratic formula? Owen, is that what you had on your piece of paper?
Yeah.
Same.
We've made it. We've made it because of the completing the square process. Okay. Raise your hand if you helped me last time clean the desks. Who helped me last time clean the desks? Annette and Charlie? Okay. Can I do this here? Landon and Dylan. Can I have you guys clean the desks this time? And you guys are added here. Thank you.
Thank you.
See you guys. Good meal. Have a good day.
Do you get like those,
Say again?
do you get wipes or something?
Yes, so it's, easiest way I found out to do this, guys, real quick, here's one person sprays, second person wipes, and then that first person comes get paper towels to dry out the rest.
Okay.
And then just kind of figure out where people were and try to, just do those.
Okay.
So that.